Okay, hello everyone. So today will be our last lecture. Okay. So next week there will be no class. Okay, so you can prepare for your other final course, right? So today will be the last class. So I will at least give you some maybe exercise and review on probably what you are facing off on the final. Okay. Okay, I will randomly giving you some questions ranging from chapter 5 to 8, and maybe some of the questions will be combining between the chapters, and also including the chapter 1 until 4 also. Okay. Let's start from the area between curves. Okay. Start from the, I think, the easy one. Find the area. Uh, Area of the region bounded by. Is this for curves and lines? Oh, sorry, this is X. So I hope this kind of question is, I hope you can solve this kind of questions, okay? Okay, the thing is, you doesn't always need to draw the graph if you can imagine the graph perfectly, okay? So between sine x and e to the x, which one is higher at the top? Ex, right? Okay. Okay. So remember that if you have e to the x, probably will look like this, right? And it will cross the 1, right? And your sine is maximum value of sine starting from 0. And maybe this is 5/2. This is the maximum, right? So that's it. That's the area. So this is 0, 5/2. So you can exactly writing down the area, or A is from 0 to 5/2, and then e to the x minus sine x dx, and you can solve. Okay. I think you can solve this, right? It's not too difficult. And the next one is finding volume. Let me give you a question as region bounded by a rotated about y-axis. Volume of the resulting solid of revolution is okay. So the curve is y equal e to the power of negative x, and then you have line y equals 0, x equals 0, and x equal 1. And the curve is, or the region is rotated about the y-axis, and it's asking the volume. Okay, now you have e to the minus x, okay? And you need to imagine the graphs looks like if you want. And for volume, at least you have two methods, right? You have the disk method or the shell method. It depends on how you rotate and how it looks like. You can choose between two of them. Sometimes the problem can be solved by those two methods, and sometimes maybe only shell method. Okay. Okay. Now let's draw the graph. Okay. So we already draw the e to the x previously, right? So e to the negative x is actually the mirror, okay? The mirror reflected on y-axis. So I can draw the, maybe like that. Okay. So maybe this is 1. So this is y equal e to the negative x. And then let me put the other one is maybe around here. Let me just draw that. So this is x equal 1. So this is the region, right? Let me write the region maybe S. Okay, that is our observations. Okay, so this is the place that we need to observe. Okay, and rotate y-axis. So let me draw the rotations here. So I need to rotate here. Okay. Now to choose which method, you can use the rectangle. Okay, maybe you can rectangle like that to make it the disk method, or this one. It's the shell, right? And between those two, you need to choose which one you are your preference. Okay. If I think if you are using this, you will have this intersection, right? You need to know this what the x and y at this point. So you have two volume, right? Volume 1 and volume 2. But I think if you use this shell method, you need only one, right? One area that you can observe. So let's choose the shell method. So let me draw the rectangle like that. And this is the x, okay? Or let me zoom in so that you can see this is the x, and then you can see that it will be rotating like that, okay? Now the radius of this circle is, this radius is just x, right? So I can write down the volume as the shell method, 2 pi integrations from 0 to 1 x, and then the height is just this height, and height is the function itself, right? So I can write this e to the negative x, and then dx. Okay, you guess the integrations setup. You set up the integrations correctly, you still get a points, okay? But you need to solve this, okay? And how to solve this? You need to solve based on the chapter 7, the technique integrations. You need to solve this by parts, okay? By parts. Let me just set up these two. I think it's not too difficult. So I can write down 2 pi and then negative x e negative x, and then you can put down the, or maybe later the integrate the number, the constants, and the other one is this. And then you can solve it. I think it's not too difficult to solve, and you get the result is 1 minus 2 over e, right? Okay. So I think area, volume. Okay, let me give you another questions that it's not difficult to process, but it's difficult to think. Okay, it's not difficult to process, but difficult to think. So let me give you the questions. The let the function f be an odd function, and then define on all numbers, all real numbers, and then if f prime is continuous and f1 is 1, equals, okay, you need to evaluate the integration. Okay, anyone solve? You get the answer? Yes. Who else get the answer? Yeah, if you look the questions, you can separate this integration become two elements. So imagine the x is our differentiations, and the f prime become f and become negative, right? So I will set up the integration by parts. Then I will have the negative x f1 minus x. This is from 0 to 2. And then I will have plus, okay, integrations from 0 to 2 of the f1 minus x dx. Okay, now what we need to do now, we can solve the left parts. Okay, we can plug in 2 and 0. So you will have negative 2 f, and then this is negative 1. And you still have the right part, which is the integration of 0 to 2 of f1 minus x dx, right? Okay. Now, if we are looking at the informations that we have, the function is odd functions, right? And if you look at this 1 minus x here, if we can substitute with something simplify, for example, u or any variables you want. For example, I will substitute to 1 minus x. Okay. So I will have, this is minus dx, right? And then I will also change this 0 and 2, right? So when x is 0, u is 1. And when x is 2, u is negative 1, right? And I can exchange that, become 1 to negative 1 of the negative f u du, right? Or I can say, because of odd functions and we have this 1 and negative 1, I can say that this will be 0 because of odd functions. Okay, and then we can look at the left part now. Now we are looking at the f1 is actually 1, right? So we can say this is the 2f1, it's 2. So this is the answer. So now this typical questions is actually the process is not too difficult, but how you going forward with the process, you need to think. You need to think. And I think I haven't decided which questions that will be on your final, but I think half or some maybe 70% of the question will be like this. So it will be like in the calculation, it will be very easy, but you need to think harder. Okay, and I will make the questions uh, so that your work when you work, you have enough time. Okay, to think and to write. Okay, if too long, it will be difficult. Maybe one or two questions will be like you need to be very long process, but it's only a few questions like that. Okay. Okay, let me give you another one. Um, uh, is the integral converge or diverge? So if the question is not necessarily to compute the calculations, then you can use any theorem. Okay. So for example, if you see this, this is improper integral. Right? In improper integral, you have the comparison theorem in which you can use it to check whether the functions is converges or diverges. Okay. And you need to compare with other functions that you can make sure that it's already been defined and you can make sure it's converge or diverge. Is it converge or diverge? Okay, the idea to find converge or diverge. Okay. First, the idea is using probability comparison theorem, right? And to use the comparison theorem, you need to use the other functions that you can think, and you can easily calculate the functions, and you can make sure that it is diverge or converge. If it's a function, okay, it's already a fraction, rational functions, and we can just ignore the secant squared, and we can just focus on the x squared x, right? So we can compute first, make integration 0 to 1 of 1 over x squared of x. Okay, so you can compute first. You can compute first these integrations. Okay, you can compute this first. Of course, if you put in 0, it will be undefined, right? So you need to make a limit approaching 0 from the right? Yeah, and then make sure you can compute this, and you can conclude this is divergent or converge, and then you can compare these functions to our secant squared here. Okay, this is the process. Okay, so whenever you are uh, looking at the comparison theorem, you need to choose one function that easy to be calculated and easy to be concluded whether it's converge or diverge. So let me write this as with limit as, let's say, t approaching 0 from the right. And let me just write as this function. And then writing the solutions as -2x plus, yeah, half. Right? And then from t to 1. And then you still need to solve this and prove that. So it's actually having t at the bottom, right? In which it will have the infinity. So our conclusion here is diverge, right? And then we need to compare with our original questions the secant squared x over x squared x, and then the other one is this, our original function. So at least it will be this, right? And we can conclude that the integration is converges by comparison theorem. Diverge, sorry. Good, good. So you are not sleeping. Okay, sorry. Okay. Okay, another question. Let me give you the chapter 8 questions. Don't worry about the notes. I will put later all the practice notes. Oh, by the way, how about your TA? Did he or she give you like a quiz? No, or no? Give? No? Don't know? Okay. Or only homework? Only homework. The global also homework or quiz? No. not quiz, homework, right? Okay, the questions, the next question, find the length of the curve. Okay. Yeah, that's the question. So this integration seems scary, right? But actually, if you think of the arc length, it will be easy to be calculated. And I think the number is not too difficult, I think. At least 2 with the power of 5 or 4. Yeah. Yeah, not too difficult for the number, right? Do you know the formula for arc length? Write the formula first. Yeah, arc length. Length of the curve. Do you know the formula? No, the length of the curve. The formula for the length of the curve. This is the curve. But what is the length of the curve? L. Hmm? Yeah, that's important. If you don't know the formula, you cannot do anything. Nanti pertanyaannya. Kamu tahu rumus arc length nggak? Arc length. Remember arc length? You know arc length? Yeah, this one. Yeah. What is this? 2 pi? No. It's arc length, arc length. Not surface, not surface. Mm-hmm. Mm-hmm. And Wait. Oh, you remember the arc length formula? The L. Yeah, arc length, the length of the curve. Integration square root of 1 plus dy over dx squared. Remember? Yeah. Yeah, square root. Mm. Yeah, like this one. And solve. Yeah, solve. Yeah, you need to solve it. Okay. Yeah, but okay, it's okay. Gimana? Ini ada cari aja length of curve yang tentang minggu lalu harusnya. Proses minggu lalu. Mungkin 15 apa 20. 2 jam. What happened? Do you remember the formula for the length? Okay. Yeah, you can solve it, right? Yeah, easy, right? Yeah, solve it. Okay. It's 1 minus 1, 0, right? Yeah. Okay, I can write the length from 1 to 4, square root of 1 plus, let's say I'm just writing y prime, okay, squared, and then dx, okay. And because our y is defined as an integrations, we can use the fundamental theorem of calculus, right? And then we can just change the x cube and then changing here, and we can write down well, let me just write the square root and then squared and then dx, and then the squared is removable, right? Because the square removed because of the squared, and then we get the and I believe this should be easy, right? For calculation. So I think okay, the very essential part of the arc length is the arc length itself, okay, the formula itself. Okay, if you didn't really maybe not really remember the formula, okay, this is how I usually do. Okay, if I don't remember the arc length, okay, so make any random graph, okay, make a simple curve, okay, any curve, but I think the simple one is easier, like just like that, okay. And then make a tangent line, okay, make a tangent line. Any point, okay, any point. You can prove by yourself, and you need to try by yourself. If you are just writing on my notes and you don't try by yourself, you won't be remembering all the formula, okay. And then writing the triangle, and let this is dl, okay, and this is dy, and this is dx. And remember, the tangent is dy over dx, right? So based on dl squared and the Pythagorean, I can write this, right? And then I can also write this as this, right? And then I also can write this, and you can choose which one you prefer, dy or dx. Let me just writing dx squared plus dy over dx squared, and then the dx squared, right? To make it complete with our previous formula, okay? And then solve it. Simplify this formula. So dl, so 1 plus dy over dx, and then squared, and then I will move the dx outside. And then integrations. And this is your arc length. Fast, right? So you need to be able to do it by yourself. So if you don't remember the formula, draw the curve, simple curve, draw the tangent line, draw a triangle. The slope is the dl, the other one is dy dx, and you can derive your formula by yourself. Because if you stuck on the question, it's actually quite easy, right? The question is quite easy if you know the formula. Okay. So if you can remember the formula. But if not, then do this. Okay. I know sometimes in the if you're nervous, you actually like forget everything you have in your mind, especially when you're having a panic attack. Oh, and then you stuck like, oh, I don't get it. Oh, I don't get it. Oh, my calculus is doomed. Okay. Okay. Let me give you uh, a more, how to say that. This is the question that I think I won't be uh, given the questions to you, but it's good exercise, and because it's combined most of the techniques. Okay. Let me give you. It's quite simple, but it's quite difficult. But it's also good practice uh, to combine all the techniques. Okay. I can give you a clue, but maybe if I'm writing the process, do we have time? I think I can show you a few steps. Okay. If you write in paper, maybe you need maybe 2 pages. Yeah, yeah, yeah. Try. At least it has 2 or 3. Like you need to substitute with. I think first is substitute, and then partial fractions. It will have partial fractions. It's quite crazy, but it's good exercise. Good exercise. Good exercise. Yeah. I think all the techniques in the chapter 7 will be used in here. It took me almost maybe 1/2 or maybe 2 hours. But 2 hours like it's not like full concentration. Like I'm doing something else and then continue and then because it's actually quite long. But the clue is the first step. The first step is really, really essential. If the first step is wrong, then you cannot really solve it. The first step is using substitution. Substitution. Yeah. That's right. Maybe can you check the answer here? Can you check the answer here? Oh, indefinite, right? Mhm. It seems the question is very innocent. Square root tangent x. Any idea? Any idea? Mm-hmm. Oh, this is actually it is okay, but do not approach directly. Bisa juga. Wah, tapi saya malas ngerjain yang ini nih. Saya mau menghindari ini. Terus mana lanjutannya mana? Oh, masih. Ya, itu paling ini termasuk yang paling susah ini. Tapi bagus buat latihan karena dia banyak apa? Banyak teknik di dalamnya. Okay, let me give you the first step to solve this integrations. Okay. Uh, One thing that really bothered is the square root, right? Okay. So let's try to maybe substitute all the square root tangent x with maybe u. Okay. Maybe if you are thinking like using u substitution, you usually you directly derive, right? You derive. But if you derive the square root of tangent x, you can, but it will be a fractions, a big fraction, right? So maybe let's square it, u squared. Okay. Let be u squared. Now it's more simple, right? We differentiate u squared become 2u du, right? And tangent x become secant squared dx, right? So let's just write that first. Okay? Okay, and then we also can write this as the tangent squared x plus 1, right? And we can exchange the x And tangent squared is tangent squared 4, right? Okay, so it will be u4 plus 1. Okay, now we put back into our original equations and we get it's u, and then the 2u, or let me write, just make this 2u u4 plus 1 du. And I have now, okay, now how to solve this? I think this 4 is difficult, right? It seems difficult. Now the question uh, is there any method that you can directly calculate this? Is there any method? Substitutions, integration by parts? That will be difficult, right? What else we need? What else? The techniques that we have that can solve this? Hmm? What? Squared? And other techniques? Can you make this whole fraction become a partial fraction? Can you think any method that can separate these two? It is if the denominator can be factorized, right? Can you factorize this? Actually, yes, you can. But you need to. uh, this is quite complicated. But if you can solve, and by the way, you need to solve it to factorize the u4 plus 1. So let me write the if I have u squared plus 1 squared, just checking the okay, so I need to minus 2u squared, right? So let me write the and then I need to minus 2u squared. Okay, at least uh, a little progress, right? Okay, if I'm writing this 2u squared as the squared, I can write square root of 2u and then squared. It's the same as 2u squared, right? Okay, we can separate this, right? Right. So the first term, this a is u squared plus 1, and the second term b is the square root to u. It will be like really long and crazy, but actually it's solvable, right? It's solvable, but it's long process, but actually it's solvable. It's not like difficult to think, okay? But it's actually solvable. Okay? So we can separate becomes u squared. Let me write the plus squared 2u plus 1. And u squared. Now minus square 2u plus 1. Okay. Actually, if you want to looking more in order, you can write square plus 1 plus square 2u, and then this is also, this is a, right? This is b. Now we have these two factors, right? And we can separate, and we can use the partial fraction. Okay. But then I will skip the process and I will give the notes, the full notes to you. Okay. But you can try by yourself. Okay. Find the partial fractions. Inside the partial fractions, at least, okay, if you have fractions like that, the most possible that you can get, okay, remember, okay, almost in this semester, almost all the partial fractions, okay, you will have this this uh, this form, or you will have just like maybe 1/x dx. So it will be resulting ln, and it will be resulting tangent inverse. And actually, after you did the partial fractions, you will get at least these two forms. Okay, you get the ln form, and then you get the tangent inverse form. Okay, you can try if you want to exercise by yourself. Okay, let me give you another question. Let I is equal limit yeah, from the right. Or maybe the question is maybe provided the limit exists. Okay, that's maybe better. Anyone solve the limit? Oh, yeah, I think it's correct. Hmm? I start thinking this one. Actually, yes. Let me give you a hint for this one. You need to think. Like if you have 1 to x plus 1, or maybe it's easy to this one. Now you have to run. So this part should be the derivative of this, right? You need to the last one maybe change this. That you can make out and from here. Manipulation. Okay, this is actually the concept. The first is it's limit, right? So limit, let me write limit exists, and if you write down the whole thing, and let me write as limit x approaching 0. Let me write the integrations, and then this actually like this, right? If you imagine the 0, if you plug into the bottom, it will be 0, right? So limit will be exist if the if this also 0, right? Right? Because if this part having a value, then it will be undefined, right? But because it's 0, the limit to be existed, this top equation should be also 0. Okay. That means if you have 0/0 situations, you can derive the formula using L'Hopital rule, right? So we can derive the integrations. Let me just write down the ddx. Okay. So we can plug in the formula. So plug in and you get the 1 minus x cubed plus 1 minus x, right? And 1. Yeah. Now we can see the limit. So it's half. the bottom one is only one, right? The x. Okay. So using L'Hopital. Okay. So let me make notes from here to here. It's L'Hopital rule. So the bottom one become one. Okay, become one, and then you need to derive the integrations and plug in the limit, and it's half. Right? So plug in this. Okay. Okay. That's the regarding the limit and using the fundamental theorem of calculus. Uh, the other type of questions that maybe I will consider is um, and this is equal. Okay. So you have a limit as n approaching infinity, and you have this long sum, right? 1 over n cubed, 4n squared plus 1, and then 8n cubed. Okay. Now think first um, and solve the limit. Okay. So remember, every limit and sum, it will be resulting the integrations, right? So the first step that you need is to rewrite the sum process into integrals. Okay. And so find the integral first, and then if you have the integration, solve the integrals. So two process, okay? From this sum to integration, and from integration to the numbers, the answers. So something that you need is probably this definition, right? I just set b is 1 and a is 0. So you can just have delta x is 1 over n. So delta x is the one that will be the dx, right? So you need to extract the 1 over n from the formula. And can you do that? Can you find the 1 over n? And then also later you will have the xi. And usually, okay, to give you the idea how to solve this, okay, so delta x is already 1 over n. So your x is actually something that has the 1 over n. Okay. So whenever you extract 1 over n from this calculation, you need to see, is there any 1 over n that you can exchange to x. Okay. So usually the x, let's say xi is having the maybe 1 over n, or maybe I over n. Okay. Something that has over n. This is just example. Okay. So for to give you an idea, if we see this n cube, if we extract 1 over n from this n cube, it will be n squared, and you don't really have the other 1 over n, right, in the calculation. Okay. What if I'm taking n squared out, and that will be my 1 over n. This will be 4, and this will be plus 1 over n squared, right? We have 1 over n now here. Okay. So let me give you the what I mean by that. Okay. So let me write the limit, and this will be 1 over n. Let me write the square root first. So 1 over square root of 4 plus 1 over n squared. Okay, because I'm factorizing the n squared outside, become 1 over n. Okay. Then I'm writing the 1 over n cubed. Okay. And this will be the same thing here. Okay. I will extract the 1 over n, and this will be 1 over 4 plus 4n squared. And it's still 1 over n cubed. And do that until we have 1 over 4 plus n squared, and this will be n cubed, sorry. So from this pattern, we get this 1 over n, 4 over n, right? So if we are looking at x is our 1 over n, okay? Or maybe I'll just write directly. So if our b is 1 and a is 0, then I can write the 1 over, this is 4. Let's say this is the x squared, because 1 over n is our x. And well, 1 over n cubed is x cubed, right? It's x cubed. So I can write this multiplied by x cubed, and then the x, the 1 over n. So we need to solve this integrations. And it's not over yet, then we still need to calculate this. And I hope you can solve this. Okay, can you solve this? Can you solve this? Okay. Okay. Idea for you. Okay. Strategy. Okay. This is rational function. Okay? Something over something, and we have this square root. So notice this square root. Okay. So every time you're having rational function, having square root, and the inside is perfectly constant, and then some variable squared, you can exchange this with the trigonometric functions, right? Okay, that's the strategy. Whenever you find rational function, you have the square root at the bottom, and you see the constant and then the x squared, or maybe maybe 1 minus, or maybe x squared minus. It also can happen, but this is 4 and plus x squared, right? So you can exchange x with trigonometric functions, okay? And you can use the relations. You can use this relation. Let me write all the possibility, okay? Okay. So I believe the tangent, right? Okay. So if we are let our x is it's 2 tangent, then the x will be 2 secant squared theta d theta. And we can solve it. Let me just write integrations, and 8 tangent cube theta, and 4 plus 4 tangent squared is 4 secant squared. So I will have 2 secant, and then the other one is 2 secant squared theta and d theta. Let me solve this first. So now I have tangent cube and secant theta. Oh, don't forget to change the endpoint, okay? So since the x is 2 tangent theta, so tangent theta is x over 2. So theta is tangent inverse, right? So this starts from 0, and this will be tangent inverse x over 2. Oh, wait, x is 1, so we can just change x into 1 over 2. Yeah. Okay, now solve it. We tangent cube. Let me just write this. Okay, now how to solve this? Okay, remember the part from the chapter 7, the trigonometric integrals? You have tangent cube, it's odd. You have secant. You can make it uh, having tangent squared and then secant tangent. You can try some substitutions, okay, some substitution, and make sure the substitution will clearly remove the other elements. So maybe the best way is if you look at this, and it will have the secant theta, tangent theta, right? The tangent squared we can exchange to secant squared theta minus 1. And let me just write secant theta, tangent theta, d theta. So I will use substitution of secant. So with u is secant theta, I will get secant theta, tangent theta as my derivatives. And this will remove this, okay? Let me write here. So 8 u squared minus 1 is it's du. Okay. Now we need also to change. So theta 0 So u is secant 0. Secant 0 is 1, so the bottom is 1. Theta is tangent inverse half. U is secant tangent inverse half. What is this? Uh, so theta is 5, 5, 5, right? So secant will be what? Secant theta is square root 5 over 2. So this will be square root 5 over 2. Yeah, quite long. Okay. Yeah. And then we can solve this and write down the solution and putting all the number and 5, 5, 5, 5, 5. 5 and then minus 1 over 3 minus 1. Uh, what is this? 2, oh, 7. 7. Yeah, I think this is the answer, right? Or you can, it is correct? This is correct? Minus, right? Oh, sorry, sorry, sorry. So it should be minus, right? Should be minus. Hmm? Which one? 8. Oh, yeah. The 2, the 2, the 2. Yeah, 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 yeah. So 2. Mm, well, let me just write this. Is this correct? Oh, no, 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 because the other one is not having a. So I need to erase all. Is this correct, right? Yeah, now it's correct, right? So 24, 12. Oh, so negative, negative 7. Now it's correct, right? And then we multiply. It's 3 and maybe it's 16 over 3. Yeah, yeah, okay. Yeah, quite long, but uh, the first thing that I think will be on your final is how you are able to exchange this limit. Okay, so I will give you some back limit. with the sum plus 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 plus, and you need to exchange to integrations, and you can evaluate the integrations. Okay. Okay. But I think this is it too long for you? Too long, right? But maybe a little bit easier than this. Okay. 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 I think that's it for today. Okay. Uh, I hope you get a good result for your final. Okay. So, uh, any questions first? Any questions? So next week there will be no class. Okay. No class next week. So this will be the last class. Uh, can we have a photo session before before we dismiss? Okay. Or do you have any questions first? No. Okay. Can we have photo sessions? So enjoy the moment before the final.